Hi, everybody. Welcome back to another episode of Space on Earth. My name is Taylor,
I'm Lacey. And I'm Pascal.
and today we're going to be talking to you guys about sound in space on different levels. So, we're going to be talking about sound in the traditional sense of what we would be hearing, and also different forms of sound in terms of how celestial bodies radiate wavelengths and how we can interpret that as sound. And finally, we're going to go over how that can be interpreted as art. So, Pascal, do you want to get us started with how sound behaves in space and talk about that a bit?
Yeah, I'd love to. Okay. So, first of all, sound is a wave, and the way it travels through Earth's atmosphere, or like when you're just talking person to person, how you hear is because there are waves that reach your ears and they're vibrating. So, sound waves are a mechanical wave, and mechanical waves are a type of wave that need a medium to move through. So, basically, they need particles to move through. Sound waves are mechanical waves because they move through the air, and the air has particles in it, like, or particles, molecules, oxygen, nitrogen, that sort of thing. And so sound waves work because they are able to create differences in pressure in the air that spread out like as you could visualize like a wave. And those differences in pressure can be detected by human ears via our eardrums. And so that's what sound waves are. They're physical, like differences in pressure in the air. Because there is no air in space, because it's a vacuum, sound can't travel the way it does on Earth. And so, for example, like two astronauts, if they made noise or tried to talk to each other, because there's no particles between them that could carry those like vibrations through the air, they wouldn't be able to hear each other, which is why astronauts use radios. But at the same time, there are, and yet we do have sounds in a sense, those should be in quotation marks, that we can hear from space. Do you want to talk a little bit about that?
Sound needs a medium. And since that's not in space, like that doesn't work. So, say you have like two astronauts in space are staying like right next to each other, even, and they're speaking to each other, would they be able to hear that sound?
No, they wouldn't, because the way our vocal cords produce sound is a like they vibrate, and that vibration travels through the air to reach other people. But because there is no air to travel through, the vibrations don't really go anywhere.
So, what stuff is out there in space that could create something similar to sound that we could collect as data?
Yeah. So some things that space is filled with that we can receive data from is plasma, which are charged particles. We also have electromagnetic waves, which do not need a medium to travel through. These are ranging from like light is on the electromagnetic spectrum, radio waves, gamma rays. Yep, I think that's it that I can think of. And those can travel through space. And then we also can have magnetic field fluctuations. And we have spacecrafts and devices on Earth that can record those changes, and that those other waves or those particles coming to Earth or coming into Earth's orbit, such as Voyager 1, Juno, and a lot of and NASA has some instruments that collect that data. Scientists then can then convert these signals into audio frequencies, which is a process called sonification. So we're not really hearing space, but instead we're turning other types of data that we collect or that scientists and astrophysicists collect into sound so that we can process it or find something new in that data we have seen before. The result often are eerie whistles, hums, and crackling sounds. So, generally speaking, space can't carry sound because there aren't particles or enough particles in space. But it does carry other types of vibrations and fluctuations in like magnetic fields, or there's also like particles that come to Earth. And those particles and fluctuations can then be translated into sound. Yeah. And so this leads to celestial bodies having unique sounds. Lacey, do you want to talk a little bit about that?
Yes, of course. Some celestial bodies that emit sounds is the sun. It emits pressure waves and plasma oscillations, and when it's sonified, it sounds like a deep rumbling or roaring sounds. And solar flares create crackling bursts.
So that's super interesting that the sun creates kind of its own like sound and its own information. And so when we think about other planets, including in our solar system, what about Jupiter? So what from Jupiter could be emitting data or waves that we could collect as sound information?
The data that we get from Jupiter is strong magnetic fields. Radio emissions get picked up by spacecrafts, and the sound that it makes is like sci-fi laser blasts and sometimes weird, eerie whistles.
Do other planets kind of have a similar effect?
It doesn't have the exact same effect. The sound that it resembles is wind or distant rain, and the emissions from that is collected from plasma wave interactions.
So it's really cool to hear that we have all this different like types of data and forms in which that's being presented to us throughout our own solar system. And each of them is individual, kind of like how you were saying that Saturn is different from Jupiter, both in how that audio sounds and where we get it from. Thinking like on a larger scale outside of our solar system, what about an object like black holes? Does that emit a sound or some sort of frequency that we can then turn into sound?
In 2022, we got a sonification of Perseids's galaxy cluster's black hole, and the sound had a haunting low droning tone, but to the human ear, we wouldn't be able to hear it. So it was pitched up so that we could be able to collect those sounds.
Quick thing, can I just quickly say something about the black holes thing? It's like yeah, the black holes were really cool because I actually distinctly remember like the year or like the day when like NASA released the sound that black holes make. I distinctly remember being in the kitchen and my dad was like, "Oh my gosh, Pascal, do you want to listen to a black hole?" And that's actually like not a core memory, but definitely something I think of when I think of like space and how cool it can be. That's like kind of like one of those points where I can pinpoint and was like, that was a moment where my mind was blown by like just like science and the fact that I could listen to a black hole. And I just really vividly remember that. So I think it's awesome that, yeah, we can listen to all of these cool celestial bodies and that we can turn that into something that us as humans can understand. I think that's awesome.
Yeah, so that's super cool, Pascal. And I totally relate to that. I've had a bunch of moments kind of similar to that where you learn something or you witness or hear something in your case that really is exciting. And that's kind of part of why scientists use sonification is because, it's one thing to just release numbers to the public and be like, hey, these are the different waves that we're getting. But to a lot of people who maybe don't know how to read that data, it's not as interesting or accessible. So, sonification is a medium that scientists can use and astrophysicists can use in order to share data with the public in ways that are exciting and fresh and accessible. Because think about it, the idea of being able to hear a black hole or being able to hear the sun or other planets is not something that seems plausible, but it's something that we can do through processes like sonification. And that really brings us into how we can apply these sounds. And a big way that we can do that is through art. And there's a lot of artistic and creative components to sharing data, whether that be, through sonification or if it's from an image that we're releasing. A lot of times, images of galaxies or nebulas are taken from data that we have, and we turn that data into more visual compositions. So, when we're talking about art, and in this case, we're really specifically talking about music, you can use planet and space sonification data for music, which is super cool, and that opens up, like, a whole world of possibility in terms of combining science and art, which is what STEM arts is all about, and that's a big part of our program. And so I'm really excited to get to talk about kind of this overlap here. So a lot of ambient and electronic artists actually use space sonifications for inspiration for their music. Which, I mean, think about it. People use stuff around the Earth all the time for inspiration. Why not also use stuff that's in space? And a lot of sci-fi films also use the sonification audios and that data to be able to create their soundtracks, scores, and any sort of sound effects that can really make that feeling and that vibe of space just come to life even more. And this was really a big influence in Interstellar, which is an incredible movie. And Interstellar used a lot of those like cosmic scale sounds and a lot of that inspiration for the soundtrack, which is also just like a really cool fun fact if you're a film nerd like me. I think that's super cool. I've been working with music and sonification through a program that STEM Arts Lab is offering, where we're figuring out how do we take data from space that's been turned into audio, and how do we find a creative way to use that and express that. So there's a lot more to it than just wavelengths and data. There's a huge world of possibility in art and creation, which is so exciting to me. And this can also be used for visual arts and media because, similarly to how we can take data and change into one form, we can also do that with the sound. So a lot of artists will translate space sound waves into waveform sculptures, digital animations, or interactive installations that use this sound and these wavelengths that we find for visually creative purposes, which is really cool. So kind of like I was saying that there's just this whole world of possibility. We can also use these sound frequencies for light patterns, color spectrums, and physical 3D shapes. Color spectrums is a really big thing within space data communication because, for example, and I brought up nebulas earlier, what we can see with our visual eyes isn't the whole picture. So a lot of times we'll take other wavelengths that we'll find and we'll convert them into color spectrums that our eyes can see. And you can also do that with frequencies. Higher frequencies, so different colors have different frequencies, for example. Reds and warmer tones are lower frequency, and blues and purples are higher frequency. So if we have a piece of sound where some of it's more high pitched, some of it's lower pitched, we can transform that into color, which I think is super cool. And this just really makes space accessible, experimental, and creative. And it opens up a whole world of opportunity for artists. So, any of you guys who are listening, if you're into creating art or if you just really appreciate it, check out sonification, see how you can play with that because there's a lot of different stuff. And I kind of have a question for all of us, so I can answer it and then you guys can add your responses. Do you guys think that turning space data into sound can change how we emotionally connect to the universe? Personally, I think that it does because Pascal, kind of like you were saying, when you heard a black hole for the first time, it really inspired a lot of curiosity and interest for you. And I've had that same reaction through seeing data in different forms. So I'll pass this on to Lacey. Lacey, what do you think about how it changes how we emotionally connect to the universe?
I completely agree with you, Taylor. It makes us more connected. We people see space as something so far away, with and we connect through each other through sound and through visually seeing stuff. We can see pictures of our galaxy, but we may not have always been able to hear it, or we have not always been able to hear it. So being able to hear it connects us even further. It shows us that isn't as far away as we think, and it's not as out of our brains as we think it actually is. We are actually quite connected when we can hear the things that we are seeing. How about you, Pascal? Do you have anything to add on this?
Yeah, totally. So, of course, jumping off what you guys have been talking about, I also think it's really interesting because, like, first of all, we experience the world through all of our senses. Like, we touch things, we smell things, we hear things, we see things. And so, when you only like know something through one of your senses, let's say sight, for example, like if you've only ever seen images of space, you can only like it only registers in your brain as something that can only be seen. And so it feels farther away. And like Lacey, y- you mentioned that like you can really connect with something when you can hear it as well as see it, and I totally agree that just, like, being able to really immerse yourself in things that may seem so far away can be really cool, and just I think it's really helpful as well to make space feel less far away is to be able to, like, listen to it and be like, "Oh, it's really here, and it's not just, like, these pretty images, but it also these sounds." And I think that's really cool that you can interact with it on different levels, and those different levels can actually give you different insights to our solar system or black holes and, like, all of space, and I think that's awesome.
Okay, thank you guys so much. Those were really cool responses. And also something I just thought of to throw in, because we've been talking about how it makes more space more accessible, especially if you don't really know how to just read the data on its own. Sonification also makes information about space more accessible to people who can't hear as well, or to people who can't see as well, or to people who can't see at all. If they're not able to see like visual images of something, they can still hear it, which is really cool. And it's really neat that we have that resource and that way of communicating this data. So that's kind of what we have for you guys today. I had a lot of fun with this episode. Thank you all so much for listening. Your support means everything to us. And also for any of you listeners who have a question about something or are interested in a topic that you'd like to hear about in an upcoming episode, please feel free to reach out to us at STEM Arts Lab. We'd love to hear from you guys, and we'd love to incorporate your ideas into our show. So, thank you again so much for listening. I'm Taylor,
I'm Lacey.
And I'm Pascal.
and we'll see you all next time. Brought to you by the Astro Youth House chapter from STEM Arts Lab, Space on Earth is a student-led podcast that inspires listeners who are curious about space to explore the wonders of the universe through the voices of young thinkers, creators, and dreamers.
Each episode blends personal curiosity with scientific discovery, from the mysterious depths of black holes to the practical impacts of space on Earth, like GPS, climate science, and medicine.
Hosted by STEM art students from Taos, New Mexico, this podcast draws connections between space, art, and science, how these things all impact us here on Earth, and their meaning to humanity.
You'll hear raw, insightful conversations about topics like light pollution, the overview effect, lunar exploration, and the societal impact of the space race.
Whether you're into exoplanets, dark energy, or just stargazing from your backyard, Space on Earth makes space personal, accessible, and inspiring. We believe that space isn't just for astronauts and scientists, it's for everyone.
Join us on this adventure as we explore the cosmos from Earth. one story at a time.
Special thanks to the Lore Foundation for helping launch this podcast.